Then hard disk is an example. If you look at hard disk is a rigid metal and or a glass platters covered with a magnetic recording material. So it is hard is made up of a magnetic material and is being divided into tracks and sectors. Okay, so it is like something you can go for. Like this is the disk. If you take, then this disk is being divided into in this particular portion. Okay, so this is going to be your sector, right? And this particular section is going to be called as track. Okay, so track 0, sector 0 is going to be your OS part. Okay, so disk surface is logically divided into tracks and sectors. You need a disk controller for managing the activity of this particular disk. What you need is disk controller. This determines the logical interaction between the device and the computer. And now we have a new mechanism of disk that is called as SSD. This is called as SSD. SSD stands for solid state disk. Okay, so this is called as solid state disk. Okay, so it is usually faster than your hard disk. This has a faster seek time. So it has means what? It has minimum seek time, so that you can access the information very fastly. So this is important. Hard disk is like particularly having low access speed, so the seek time is slightly lower than SSD. So apart from this, there are, say, optical disk also. You can take this optical disks. So you can use this optical disk as compact disk, or right, CDs or DVDs as an optical disk. Then apart from this, you can have removable storage medias. Removable storage medias. Okay, so this removable storage medias, for example, you can go with this is particularly plug and play, PNP nature. So plug and play, and you can go for it as pen drive. You can have this as a pen drive, or you can have USB storage, right? You can go with USB storage hard drive, right? So this is going to be important as far as storage structure is concerned. Okay, so if you look at the storage structure, it is being broadly classified into two: primary and secondary. So primary memory primary memory is mandatory memory, which is being divided into again two classes: random access memory and read-only memory. So if you look at read-only memory, again you have three different classes: PROM, EPROM, or EEPROM. Then you can use this particular read-only memory as a BIOS, as a startup routine. We call it as a BIOS routine. So it is nothing but basic input-output system. It is executed at once. Basically, the intention of writing BIOS is to check the integrity of the system in terms of all connected components, right? So in case of IO devices, it is like there are two classes: broadly mandatory and optional. So there are certain examples of it. You can go and search it out. Now BIOS is helping us to determine the boot up sequence, the booting up of operating system. So what is boot up? Booting up is nothing but loading an operating system into primary memory. So basically OS resides onto a secondary storage, and then it is being taken up to a random access memory. So If you look at random access memory, it is completely volatile in nature. You cannot store the data permanently. It is represented into a matrix form. And then you need to understand that the primary memory always comes into a fixed sized memory. Fixed size memory, it is a standard memory. It works with respective to the architecture of computer. It is being provided in terms of slots, so you can extend the size of the memory. See, if example, for example, if your computer is support is with the 4 GB of RAM and can be extendable up to 16 GB, which means that you can if you have 2 slots of memory where 4 GB's memory is being put into a slot one, then you can have an option to extend it as an 8 GB, 8 GB, it becomes 16 GB, and likewise. So it is in that case, if you really wanted to extend it further, then you can take a use of secondary storage also. So if you look at secondary storage, which refers to the non-volatile section of memory, which will allow us to store the data permanently. The data which is stored onto a secondary storage is in term of files, and we understand that file is always a processed information, whereas whatever the data which we store onto a primary memory is in terms of raw data. So processed data always goes on to a secondary storage. Okay, so this is what is really very important. Now, if you look at an example of a secondary storage, so a secondary storage best example, yeah, secondary storage best example is your hard drives, hard disks. Okay, this is hard disk. So hard disk are being basically a magnetic material, magnetic recording material. So previously in good old days, like it was like we have used magnetic tapes also as in a secondary storage. Computers were using a magnetic tapes for secondary storage. You may have seen this kind of mechanism in audio cassettes, audio tapes. If you have such kind of system at home, where instead of CD you have audio tapes, so there you'll find that the structure is going to be like this. There are two wheels, right, and these wheels moves in either direction. So, and the magnetic material is being wounded on this particular wheels. Okay, and there is a reader actually head which reads that data onto magnetic tape. Okay, so this kind of structure we were having as a magnetic tape, as a storage structure, but later on it is being converted into a random mechanism. It was a sequential mechanism, but later on it is being converted into a random mechanism where a digital metal, rigid metal or glass platters are being used for formation of the disk. The disk is logically divided into tracks and sectors, which I have shown it here. Okay, tracks and sectors. So to manage this particular mechanism, we need a disk controller. Okay, so this is important, disk controller. Okay, now later on this hard disk, which is magnetic material disk, is being converted into SSD format. Otherwise we do have some removable storage medias also. Just to take an example, removable mode storage media with respect to the optical storage, it is called as CDs and DVDs. In case of removable storage in a magnetic material, it is basically they are plug and play. You can take an example of pen drive or USB storage hard drives. So this is how it is being done. Okay, so as far as storage structures, these are the points which you need to consider. Now, if you look at storage hierarchy, they are being classified in terms of speed, cost, and volatility. Okay. Okay. So means type speed stands for uh, shortest seek time. Seek time means how fast I can reach out to a particular cluster, right? How fast I can reach to a particular cluster means like you have this kind of mechanism. These are what? These are nothing but tracks, you can say. Then if this has been divided into this particular section, this becomes a sector, and the smallest unit is going to be a cluster. Smallest unit of this track and sector is going to be a cluster. Okay, you can take it. Okay, or you can go for a location or disk location. Okay, so when I wanted to go at particular some location of the disk, then I certainly require a time, and that particular time is nothing but that time is associated with respect to the movement of disk head, right? So that so that is called as shortest seek time. So means the time required for moving ahead from one particular disk location to other particular disk location. So it is called as seek time, right? Okay, time of access of a disk location. Okay, so this speed is one criteria, cost is one criteria, and volatility is one particular criteria. Then you need to think about the caching. Caching means what? Copying information from faster storage system, where main memory can be viewed as cache memory for a secondary storage. Okay, so in the next slide we will be having a better example of this particular mechanism, right? So here if you look at, if you have a file, the information is like, if this particular file, then file has certain attributes. Say file has certain name, file has certain name, then file has certain starting address, starting address.
Sir,
This starting
it's
address
getting so noisy.
will be
We
like,
are not able to
huh?
understand.
You are not able to listen me. Okay. Okay, so not a problem. Let us see whether the network is getting stable or not. Okay, so the file, every file has a file name. Every file has a starting address. This starting address consists of a track info, a sector info, and location info. Okay, so this is important: track, sector, and location info. So this is there. Then with respect to this particular file, you have size associated. With this particular file, you have type associated, and with this particular file you have application, also application information. Okay, so this is basically particularly stored onto this. Okay, so this particular information, this whole information is being stored into FAT. Can anybody tell me what is FAT? FAT, what exactly it is? Yes, can you tell me what is FAT stands for? What does this FAT stands for? FAT stands for
Field effect
file.
transfer.
Yes, FAT stands for file allocation table. Okay, so FAT stands for stands for file allocation table. Okay, and this is the primary source for for seeking any information from a secondary storage. This is file is primary source for seeking any information that is present on the disk. Okay, so it means that if you want to access certain data from the disk and you need to determine the speed, so this is playing an important role. So so from this particular file allocation table, what you will get with every name you need a starting address. This starting address contains track information, sector information, and location information, so that this particular information is really important for the movement of disk head, right? Head, and this disk head is being controlled. This movement is of disk head is being controlled by whom? By disk controller. So this is important. Okay, so this speed is there. So based on, like, if you have a high speed disk, the cost of this particular disk is higher. So means what? If you look at this cost parameter, right? So uh, low seek time cost is higher. High seek time it is cost is lower, right? This is speed is also slow. This is speed is fast. Okay, so this is important. This is the criteria. Okay, now here the device drivers are playing important role. So this since this um, hard disk is an hardware, to get this information maximum throughput from this hardware, you need a device driver. So device driver for each device controller to manage IO operation, this device driver provides a uniform interface between the controller and the kernel. Kernel means what? The part of operating system, right? Kernel is actually daemon, and this daemon is nothing but what you can say, mm, active process of OS, operating system's active process, so which remains active till the operating system is active into a primary memory. Okay, so if you look at this, the storage hierarchy is like the registers are the smallest unit. This is the smallest unit of your primary memory, smallest unit. Then registers, cache, main memory, solid state disk, hard disk, optical disk, and magnetic tapes. So uh, if you look at the storage hierarchy, storage device hierarchy. So this is at the zeroth level, right? This is at the zeroth level, or you can say a magnetic tape to optical disk to hard disk to solid state disk, main memory, cache memory, and register. So register is at the lowest uh, what you can say, uh, the smallest part of the device hierarchy, right? So the smallest unit, so registers are going to be smallest unit. Means what? If you look at this particular primary memory, if it is m by n, right, which is nothing but a matrix structure, then every location is nothing but every addressable location is nothing but a register. Same is what? If you refer back to any location here, any location here, say for example you are referring to this particular location, so this particular location is registers. Okay, so this particular, so it is like m by n is a matrix of registers actually, of registers. So registers are the smallest unit or the lowest segment of a storage hierarchy. So tapes are the highest one, right? then the optical disk, then the hard disk, then the solid state disk, then you have main memory, then cache and registers. Okay, so this is lowest one, and this is the highest one. Okay, so this is the difference as far as